Welcome everyone to the June edition of Ask Tom's Office Hours with regards to the Autonomous Health Framework. Joining me today is Barry Gleeson, who's lead developer on the CHAG Finding Explorer, which we'll be talking about today. A few words of introduction here. First off, this is being recorded. Everybody is on mute except Barry and myself. We will be taking questions via chat. So if you want to ask a question at any time, simply type it in the chat window and we'll get to it during the course of this session. I want to point out that this session is not in lieu of any support help for specific problems. We're not our replacement for Oracle support services, so please don't direct specific questions, try to make them general. However, we will hopefully help you in that regard to the extent we can. I also want to point out our safe harbor statement in case we talk about, since we are talking with development, in case something is mentioned that is future facing, please be advised of this safe harbor statement. This is a Q&A session, even though we will be talking about a particularly newly released tool, but nevertheless, if there are any initial questions before we get started, I do have a bunch of seeded questions which we can follow, but anybody who wants to put in the chat any initial questions, feel free, and we will get to them. Barry, why don't you just introduce yourself, give us a little bit of your background.
Okay. My name is Barry Gleeson. I've been at Oracle since, I guess, 2004. I've been working primarily on performance management, but I've also been involved in the Cluster Health Advisor work, and in particular, I'm interested in sort of big picture, how do we figure out what's going on in a data center and what needs to be paid attention to. And the CHAFE Finding Explorer is a step in that direction, I think. So.
Okay. With that in mind, let's start with an initial question. That is, what's Oracle's goal in developing this Finding Explorer?
So quite often we will get stuff coming in from customers that has been produced by CHA. In particular, the query diagnosis option of the CHA CTL command produces an HTML file, which when you've got a small number of problems is actually really helpful. It shows you when problems started and ended, which targets they applied to, and so forth. But sometimes we get HTML files from customers that are very large, and that creates a challenge in trying to figure out what's the most important thing to look at. Where should I start? And it was for analyzing and getting an overview of large query diagnosis output files that we built the Finding Explorer.
I see. So you mentioned about this HTML file. Can we see an example of one?
I'm hoping that you can show us one right now, Mark. Oh, there we go.
Okay.
This shows for each target timestamps for when particular problems were detected and when the problem stopped showing up. You see the rightmost column, it says either detected or cleared. And when there's half a dozen rows in a file like this, it gives you a clear idea of when things started and stopped, which targets are affected, and what kind of problems they had. But when you have hundreds or thousands of these, figuring out what to pay attention to is a little more challenging.
Mm-hmm.
So perhaps we could have a look at how this particular file looks when we use the child finding.
I was going to ask you about how it looks in Child Finding Explorer, and
yes, here we go. Well, now what we're trying to do is give a graphical, high-level overview of the contents of that file. And so you can see that this is organized on the left-hand side, in the y-axis, you can see a list of different problems. Mark, can you zoom in so people can see that, can read that, the left column there?
Yeah, well, everybody's on their monitor, so
yeah, so they okay.
Advantages.
So each row, each horizontal row in the graph corresponds to a particular kind of problem. So the second row, for example, is private network messages dropped. Across the bottom of the graph, you can see timestamps. And this particular file, which is it's almost 2 megabytes, this file, covers a week of data from a cluster with 3 machines, 3 machines? Yeah, 3 machines and 6 database instances. So what we're trying to do is show across the width of the graph, when did the problems occur, and up and down the graph, what kinds of problems. And then the colors show which target encountered a particular problem. So, for example, can I point at this? Can people see my pointer?
No, they can't.
They can't.
Okay, so
yes, you can point at that orange long bar. That is host mynode 3 having a DB control file I/O performance problem for quite a few hours. You can see it goes for most of the day, from noon on the 25th of February, almost to midnight on the 26th. So that's almost 24 hours there. You can see lots of other problems that came and went at different times. So that's the basic layout here.
So so obviously you've answered sort of what how the view is organized here,
right?
How do, and you've sort of also answered when these problems occur with regards to, I guess, these time axes, correct?
Yes, exactly. And in this view, we're seeing the entire period of time that was covered in the file. So when the CHARCTL query diagnosis command was issued, there was a start and end time, and we're showing all the problems that were within that time interval here, a week.
Okay. So I don't get the exact timestamp by, as an example, hovering over alt text or whatnot. I just get a sense of when during the day it's occurring.
Exactly. I mean, the goal here is to get an overview. And for example, if there was a pattern that something was happening at the same time each day, it would show up visually quite clearly here.
I see.
In the bottom row, for example, the second bottom row, the ASM disk utilization thing, you can see that this is happening periodically. It comes and then it disappears and then it comes back.
Right. Okay. So if I want to look at how are the targets rendered in the graph?
So in this picture, the different targets are shown as different colors. And that's what the legend is down at the bottom. Now, this does have a bit of a challenge, which we'll talk about again later, where if multiple targets are having the same problem, only one color is picked, and it's arbitrary. There is a way to show this in more detail, but we'll get to that later.
Okay, all right. So as far as the length of the problem last, I assume you were referring to the fact that obviously the width of the bar across the x-axis is indicative of how long the problem has occurred, and so I'll have gotten a cleared message. Is that the idea here?
Yeah, the longer the bar is, the longer the problem occurred. The left end of the bar is when the problem showed up, and the right end of the bar is when the problem, when Shah said that the problem had cleared. So left end is detected, right end is cleared, if you remember that column in the original HTML file.
Right. So if going here, we've got the detected and cleared for each individual problem.
Exactly.
Okay. So how can I tell how many problems are actually happening at the same time with regard to this visualization?
Yeah, you can see in this graph that particularly in the afternoon of February 25th, there might have been quite a few problems happening at the same time. But it's a little hard to tell from this graph what the counts are. And so we added a second graph. You can scroll down a little bit, which shows a count of how many problems are happening simultaneously at each point in time. And again, the x-axis is exactly the same as the one above, so it matches. The y-axis is simply the count. So you can see that at some points in time here, we've had as many as 20 problems simultaneously. Most of the time it's below 5, but some of the time it spikes. And we can see 3 major spikes in the right-hand half of the graph, basically.
So in this particular case, I've got a database that has 3 instances, and if this problem is occurring across all 3 instances, it would show up as a count of 3.
Exactly.
Based on this computation.
Right.
Okay. And so we've got both the count of problems and essentially a count of duplicate problems across different targets, right?
Right.
So how do I, can I tell how many, can I tell how many problems were actually happening most frequently from this graph?
Right. This graph is collapses together all different kinds of problems, the concurrent problem count graph. And that means that you don't get a clear idea of what types of problems are predominant. So if you scroll down a little further, we added a third graph here that basically, this one is organized by the type of problem, ordered the same way as the top graph. And the length of the bar in this graph shows you how much of the time that problem was happening, okay? And in fact, sometimes you can have, you see the horizontal axis has numbers like 1/2 and 1. So if the bar reached out all the way to 1, that would say that you have a problem of this type all the time for the entire duration of the period. We have a couple of things where we have a particular type of problem happening more than all the time, which seems a bit odd at first blush. But what's going on there is more than one target is reporting the problem for some of the time. And so when you add up the durations for all of the targets, it adds up to more than elapsed time. And so this problem is happening not only all the time, but clearly some of the time it's happening in multiple places for multiple targets. So I like this graph because it tells me which problems I ought to be really paying attention to. And for this particular customer, there were clearly 2 kinds of problems to pay attention to. They had problems with their disk configuration, and they had problems with their network configuration. And both of them, those problems show clearly here.
Okay, all right. Well, that looks quite useful. So, so can I actually, based on the fact that this is over a time period, can I actually zoom in on a particular time interval?
Yes, the graph that we've been looking at has covered the whole week, and you might be interested in zooming into a particular part of the week. And that's, if we scroll down a little further, you'll see that there is a control for this purpose.
I see. Okay, so this is the slider here that's at the bottom here. Exactly.
Sometimes you'll get an HTML file where most of the time there's nothing going on, but then you've got maybe a small period of time where there are problems. Can we switch to the other?
Sure.
Okay, this is another sample file that we got, and you can see that it covers several days from about February 1st to about February 6th or 7th. And in this picture, all of the problems happened close to the end of the file, close to the end of the time period. And so we're not seeing a very good picture of what's going on here. And so to help make this clearer, we added a checkbox a little further down. Mark, can you check the box called Shrink Time Interval to Detected Problems? Now, if we go back to the top, you'll see that what we've done is stretched out that short interval, and you'll see that it starts at about 9 o'clock and it goes to about 10:30 on that particular day. And there are all kinds of problems in that space of time, nothing before and nothing after. But now you have an idea of what kinds of problems are showing up and when they're showing up in that small time interval. You can zoom in further using the slider if you want to.
Yeah, so just by the way, for the people who are on the phone and in the chat, please enter any questions at any time. This is not totally scripted, so if you have some questions with regards to what you're seeing here or what functionality that we may be missing or issues along those lines, please enter in a question and we'll get to it in due course. So with regards to, so I'm seeing all of the problems, I'm seeing all of the targets basically, but can I look at particular types or subsets of problems so I don't have to look at everything all the time at once?
Yes,
in that regard.
There is a little further down on the screen, there's a set of checkboxes, filters we call them, one set for targets and another set for problems. And you can choose whichever problems you want to look at and whichever targets you want to look at. When you choose a collection of things, which Mark is doing at the moment, you then have to hit the Update Graphs button over on the right, and we'll redraw the picture. Yes.
So if I wanted to look sort of at memory and CPU's problems, I would do something like this and check only the ones I'm interested in.
Right. There was one saying there was a log-based one you still had checked, Mark. Log sync for global.
Yeah. Okay. There we go. And
now let's
so
update
I would.
graph. And now we have a very small set of problems, and you can see that we're having problems of these four types consistently over much of the from like 9:45 to 10:15, and all of them from 10 to 10:15. Now, this is the sort of situation where the fact that we're showing only one row for each problem type can be a problem. Here, particularly if you look at the bottom row, DB session memory consumption, my bet is that there's more than one database instance that's reporting this problem. Look at the counts, right? The count is right up to 10 problems where Mark has the arrow there. And so this graph at the moment just is picking a color, any color, of all of the guys who are reporting the problem. Now, get a better view of which instances are contributing, are having the problem. There's another checkbox further down called separate by target.
Okay, so this would be answering my question. I had this question about, can I break this down by target?
Yes.
And you're basically saying that by unchecking or by checking this separate by target button
exactly.
here, and then doing
updating the graphs. Now we'll get a different picture. When it's finished, there we go. Now you can see each of the instances separated as a group, and the problems types. See, host memory swapping appears for each database instance. Host memory swapping, host CPU utilization shows up for the host. Okay, and so particularly around 950, there's a period of time in there where everybody is reporting host memory consumption and host memory swapping, except for the gold guy. The gold guy _2, he seems to be doing okay in that period of time, but everybody else is in trouble.
I see. And so this sort of corresponds to my high count here.
Exactly. The 10 is happening because lots of people are reporting similar problems.
Okay, so this looks really useful, and a question obviously I would have is, obviously we showed this display, but how do I get here? In other words, how do I create the HTML file that drives this utility?
There's a charctl command, which I think we can show here. Charctl query diagnosis. You give a start timestamp and an end timestamp, and provide a file name to dump the charctl to dump the HTML file to. That's the starting.
That's all I need to do then to get this.
Right, and that gets you the sort of file that we were looking at right at the beginning of the session, the HTML file that has the detected and cleared rows broken down by target. In later releases, it also has some PDB-related data in it as well, and a description of the problems. So for a small number of problems, this is a really useful, this is all you need to do. But if the file turns out to be large, that's why we're here.
Exactly. Okay, so we have another GUI. It's called the CHAG GUI, or CHAG for short. How do they actually compare?
Okay, so the Child Finding Explorer is really intended to help you get your bearings, to figure out what's going on, what time periods are important, which problems are important, what do you want to drill down on. CHAG is intended for more detailed analysis. If you want to look in detail at specific problems, you want to see the evidence that led CHA to conclude that a particular problem was occurring. That's what CHAG is for. So they look at two different levels of detail, if you like. And if you only have a small number of problems, you probably only need the CHAG. But if you've got a lot of problems and you want to figure out what to focus on, the Finding Explorer is aimed at that question.
Okay, well, it looks like those tools can actually work complementary. So is there a way that these can be used together?
Yeah, the Child Finding Explorer really is intended to give you a view of the whole, an overview of all of the data of an extended period of time, whereas CHAG is designed to let you drill down into what's been happening in a shorter period of time, say an hour or something like that, and to actually see.
So like,
yes.
So like this screen here.
Here's an example of the CHAG view, and what we're seeing is details of events coming and going, and the evidence for those events over a 1 hour period of time.
But we're only seeing an hour, basically, of detailed data, where the other Explorer basically will give you a whole day or your screen with view of the data.
Exactly. Okay. So if you've got a lot of data, start with the Chart Finding Explorer, figure out what period of time you're interested in finding out more details for, and use CHAG for that interval.
Okay. So where can I find the Chart Finding Explorer?
So it's available as a download from MOS. There is a MOS note, and that's on the screen right now. If you go to that MOS note, there is a zip file that can be downloaded, and that's where you get started.
So is there a bunch of steps to install the Finding Explorer? How complicated is that?
Basically, you find an empty directory, and you unzip the file that you downloaded from MOS, and it has in it an HTML file called install.html, which you can open with a browser, and that will give you directions for what you need to do. Probably the most time-consuming step in getting the Chart Finding Explorer up and running is you have to have an installation of R, the statistics language, on your laptop or the machine where you're running Chart Finding Explorer. And there are directions for doing this. It's a download, doesn't take very long, but that's the first step. Once you've got the R installed on your machine, the second step is to run a script, which is written in R, which starts the Explorer. The first thing that script does, the first time you run it, is it checks to see whether you have a set of packages that it needs, R packages. And if they're not already installed on your machine, it goes and gets them from CRAN, which is a repository of R packages. That step requires reaching out. Both those steps, installing R and getting the packages installed, require that your machine is connected to the web, to the internet, and so there may be proxy setup things that need to be done as well. Those are all documented in the install.html file.
I see. Okay, so once I've done that, how do I actually pass the HTML file into the Finding Explorer?
So when you start the Finding Explorer, there's a screen that has a browse button on it. And the first thing that you do is you click the browse button. It'll pop up an open dialog box from your operating system, Windows or Mac, whatever, and you navigate to the file that you've saved from CTL query diagnosis, the output file from that, and select it and open it, and that will then bring that up in your browser window.
The browse button you're talking about is here?
Exactly. When you bring this up the first time, that's the only thing that'll be on the screen, the heading and that browse button. So you hit that browse button and navigate to the file, and you could do that now, Mark. to show what that looks like. And you can choose a file and away it goes. If the file is large, like this particular one is, if it's bigger than a megabyte, it may take a little while for the screen to render. It takes a while to parse the file and get the data organized. And I think about a minute per megabyte of data. Most of the CHAR CTL query diagnosis files are much smaller than that, but you can get them to be quite large. And this one that we're parsing right now is about a week's data, I think. And that turned into 1.5 megabytes or something like that.
Mm-hmm. So yeah, this is taking a little bit of time to render.
Yeah. There we go.
No, it's not.
Nope, hasn't yet.
Okay, well, while we're waiting for that to come back, obviously, what CHA versions does the Finding Explorer support?
Any version where you can run CHA CTL query diagnosis. As long as you can generate an HTML file from that command, we're good to go.
Okay, so basically that command exists since we introduced CHA in 11.2 or 12.2 rather,
Yeah.
and so any supported CHA supported version will work fine with this Explorer. However, does this in more recent versions of CHA, such as 20, we have the ability, or 19 rather, we have the ability to run without the GIMR deployed.
Yeah.
So does this tool require the management repository?
Yes, it does. The CHA CTL query diagnosis command needs data from the GIMR, the GIMR, to produce the HTML file. So yes, it does require the GIMR to be deployed.
I see. Okay, so it looks like we have some questions in the chat here. What's asked is, how much space is needed to actually deploy the CHA Finding Explorer? I assume they mean disk space here.
Yes. The CHA Finding Explorer itself is tiny. It's just a small script. The bulk of the disk space that you need is for the R installation, which takes a couple of 100 megabytes of disk space.
I see. And there's a follow-up question here. So when a customer runs CHA to generate the diagnostic file, can it have any impact in terms of performance on the production box?
The impact is very small. The command goes to the database and does a query and then does a small amount of work to assemble that into an HTML file. It's very lightweight.
Okay, so by database, you mean it goes not to the customer's database, the production database, but actually to the management repository.
Yeah, I'm sorry. It goes to the management repository and fetches the appropriate data and formats it, and that's a very lightweight operation.
I see. Okay. All right. So let's see. Do we have any other questions here from the chat? Anybody have anything else? No, it doesn't look like we've got anything. So this has been quite informative. And we are going, since it is summertime coming up, we are going to be taking our annual break. So there will not be a session in July, but stay tuned for our August announcement, because we'll be resuming the STOM sessions for the Autonomous Health Framework in August. So the fourth Tuesday in August will be our next one. And as usual, this session will be hosted on our YouTube channel, the STOM YouTube channel. And it takes about a week or so to process and get it uploaded. So feel free to pass the link around and view it at your leisure. I want to thank Barry for spending time with us this week, and I hope it was informative to everybody. Signing off.